Hello and welcome into this video series where we're going to talk about how I went about the process of building my life-size Iron Man. I'm going to begin in ZBrush. As you can see here, I am in the ZBrush interface, and I'm going to go over for a few minutes a little bit of an overview of the process that I go by to cut the model. Obviously, before you do anything, you have to begin with a model. So as you can see here, I have my Iron Man model. This model was created by Did 3D and the great work that Didier did to create this model. And what I did is I brought it into ZBrush and put it together for a couple of reasons. First, I wanted to see how overall the model is going to look like. Then I actually used some of the ZBrush tools to be able to put some paint on it to get a better idea and feel of how the model is going to look out at the end. Now, I want to highlight that this is not a ZBrush tutorial. There's a lot of great tutorials out there that you can go to YouTube and you can refer to. And there's also a lot of other programs that you can use to be able to split models up, to be able to comply with the print volume of your printer, especially when we're building something this big. Some other software applications are Mesh Mixer, which is from, I believe, AutoCAD. There's also a software program out there called Luben or Luben 3D that does some of this stuff automatically. Now, the reason why I choose ZBrush is I believe, this is really my personal preference. I find it to be a lot more flexible in allowing me to sort of slice and dice, if you will, the model in a much more flexible manner. It allows the manipulation of the geometry of the model in a very detailed, also in a very comprehensive manner. But with all that said, ZBrush has a really steep learning curve. You really got to get used to the way ZBrush likes to do things. And by no means am I an expert. I just learned enough by watching videos to be able to do kind of like some of the things that I want to do. So for example, if you wanted to learn how to put paint on the model, all you got to do is just do a simple search on YouTube for painting and ZBrush, and you can focus on that feature, learn it, then off you go. So that's kind of like how I proceeded with the usage. Now, with that said, all of these different pieces here, as you can see from the model, are different STLs that I said, again, were imported into ZBrush. I organized them in different sections here for the, let's say, the left foot, right foot, etc. So I can just organize it in folders. And, if you expand one of these things, then you can see the individual models. Now, the one other thing that I will mention is I do not do any scaling of the model in ZBrush. What I do is I work with a model in the way that it was originally created. This model, as you can see here, is the Iron Man MKVII. It's from the Avengers, and the model was originally created in 1/3 scale. Obviously, I wanted this to be full size, so I had to scale it up by 300%. But I do all of the manipulations that I need to do in the individual parts in ZBrush, and then I do all the scaling in my slicer software. I am a super slicer user, fork of Prusa slicer. You use Cura, you use Slice 3D, you can use all these other different things out there. Scaling in those slicer applications is just as easy. Now, with that said, is, looking over how you're going to begin to slice this model is obviously you need to take into consideration the print volume of your printer. I have a fairly large printer. I have a RatRig Vcore. It's a 400 by 400 by 400 build volume, which is substantially rather large when you compare it to, let's say, like an Ender or something like that. So for me, and the 300% scale that I wanted to do, some of these parts, let's say, for example, the lower part of the leg here, I only had to split it once, let's say somewhere down the middle. Now, we're going to talk about how you proceed in splitting a model. And it's not just about considering your build volume of your printer. Obviously, that's a huge consideration. But it's also about thinking and looking at how the model has been constructed. And when you do split something, to take into consideration, how is then this part, after it gets split, going to get glued together? where the seam is going to be. Is the seam something that's going to be easy to hide? Because all of that work up front, it's really going to allow you to then be able to put the model together a lot easier, glue it a lot easier, and the outcome is going to be that much better. So when I got this model, just like everyone else, I was really, really anxious to start printing, and hey, you know, how's it going to look together? But believe me, there's a lot of work to be done in a piece of software like ZBrush before you even begin to print anything. And that's to just ensure that what you print is going to come out great, but also your post-processing is going to be to a minimal. Like, for example, minimizing supports in the way that you split your model. Okay, so what I'm going to do is I'm going to bring some of these parts, individual parts, into ZBrush, and I'm going to show you the process that I go through to be able to split them, rather. And once we do one or two of this, you'll get the hang of it, and then we'll proceed with bringing them into Super Slicer. I'll try to make this as comprehensive as possible to show you every piece of the process that I used. So yeah, let's do that next. Okay, here we are back into ZBrush, and what I've done is I've imported one of the parts. In this case, I think it's the right lower foot, if you will. And again, this is where we are going to consider cutting this, splitting it into pieces so that we can print it. Now, again, depending on the build volume of your printer, you might have to split it in one location, or you might have to split it in several locations. So maybe 2 pieces versus 3 pieces, etc. The build volume of my printer, 2 pieces is really all I need. Now, with that said, also what you should be looking at, areas as to where to split, this foot. Now, imagine if you were going to print this in one piece, imagine all of the supports that you would have to put underneath here and around this area, maybe on top. But if I was going to split this thing, let's say here down the middle, right, you can see that if this top piece here was on the printer bed, there's really is no supports. And if I flip this one upside down, print it like that, again, it eliminates a lot of the supports here, a little bit of overhangs here, but with a very good tuned printer, you wouldn't have to do that. So what I'm trying to get at is take a look at the part that you have on your screen and consider the best location for splitting it. Now, again, if we split it down the middle here, you'll see that we'll also have a seam line here that will be fairly easy for us to hide it. It's not behind something. We can use some putty, all that stuff we'll describe later as we go into the finishing end. But again, it takes into consideration where you're going to split the model and how easy it will be to hide the seam. So with that, here is the process that I use to split that. I decided that I'm going to split it here. I simply go to my slice cut brush and I just drag a line across. Now I can move this line anywhere I want. And let's say I decide to split the piece right here. Okay, we bring on our polymesh. You can see that this part has now been split into 2 different parts. What we also need to consider, obviously, is that when we now go print these 2 pieces out and we want to glue them together, we want to make sure that they align. It would be very hard for us to, clamp it. It's a very odd shape, right? And also make sure that if it gets clamped or held together until, let's say, epoxy or some other glue that you use, I'll talk about that in a minute, solidifies, to align these 2 things here. So I guess what I'm driving at is we're going to need a method of keying the model, of creating indexing keys, so that when we put it together, these 2 pieces are going to align when you go to glue them. And the way that I do that is I basically use a square, a very simple square box, if you will. You'll see the process in a minute, to actually align these. So if we now take these 2 parts and we actually go to group split, what's going to happen is you're going to see that it's going to separate them into a top and a bottom part. As you can see here, the top, and we're also going to have a bottom. But notice that there's a big hole of where the model was that we need to close. that's very easy to do. We just go to geometry and we can just simply hit something called close holes. And now that hole is closed. We can actually do this for the other part as well. Geometry, close holes, and that part is closed, right? You can see there's two different poly groups. We can make them one. And then I can do the same thing on the other part, just to have one solid mesh. Okay. All right. So now with that is what I said is that I'm going to use keys here for me to be able to index this when I glue it. And for that, what I use is simply a square box. Now you can create this in ZBrush itself. You can create it in some other external program. You can even create it in a slicer if you want. So I'm going to take this. I'm going to drag it over the area where I think this key needs to be placed. Now I know I might be doing things. Bear with me. It will all make sense in a minute. I'm going to actually go on ahead and duplicate that. I'm going to use 2. Okay, and I'm going to drag the other one out as well. So you can begin to see what I'm trying to do here, right? I'm trying to create 2 areas where if I enter these 2 boxes and I make the 2 things together, the 2 parts, they're going to align. And that's exactly what I'm trying to do. Okay, we'll take this thing, place it about halfway into the model. We'll do the same thing with the other one, halfway into the model. Okay. And what we're going to do next is we're actually going to turn on a Boolean function, and we're going to hit our live Boolean button up here. And as soon as we do that, you can begin to see that this shape, this box shape, created a hole, if you will, into the model, but didn't just do it on the bottom piece, but if we bring the top piece, you'll see that that also has been done on the top. So now you can begin to see that if we print out these box shapes, if you will, and then we insert them into these areas, and then we make the 2 parts together, they're going to perfectly align. Okay? So that's the process that I go through to actually split the model and make sure that the model aligns. Now, make sure that you do not move either the top part or the bottom part, because obviously those keys are not going to align. So a couple of more steps, and then we can actually go on ahead and hide one of these. A couple of more steps, and then we're able and ready to actually export this part for slicing. We can, we can bring it into the slicer. So the way we do that now, once we make sure that we know these keys are aligned and making sure they're not overlapping anything or they're not any gaping holes, again, you can move these things to bring them into an area where it's going to make sense depending on the part that you're cutting. We actually have to go down here into this Boolean function, and we're going to have to hit something called make Boolean mesh. And what that's going to do is going to take these 2 pieces and this part and create a different part with the 2 holes together. And you can see up here that it created this mesh. Notice before we had all these different subtools, now we have a single one, and this single one is the piece that actually will need to get exported. Okay, we need to go do that for the bottom part as well. We're going to go ahead and highlight that. Okay, make sure it's selected into the subtool tree here, and make Boolean mesh. Creates it again. Creates it. So now we have 2 different. We have this part, and we have this part that can now be exported for us for printing. Okay, so what we do now, once we are happy in the way these keys look, and we verified that they will align by, not having moved any of the parts, we hit the export button here. Okay, and I like to export all my files as 3MF. And the slicer that I use, Super Slicer, reads it, but you have the option of actually using STLs or whatever else these things will support. But tell you what, let's go into an RMN directory that I have here. You see, I was playing with some of these parts, but you know, we can name it. This is the upper part 1, 3MF. As you can see here, let me just minimize this window a little bit. Okay, so 3MF, as you can see here, name it part 1. Do the same thing for the other file, name it part 2. I already did that, but just write me to overwrite. Hit select it, hit OK. And your file now has been exported into a format that the slicer can read with the proper keys here, the proper areas that we created to be able for these things to align. So we actually choose the other part here, make sure it's chosen here in your browser. Okay. And we go to the one that that we created as a mesh, you know, the Boolean mesh, and we do the same thing. We hit export. Again, I already had exported this before, but you can see what I'm saying. And you know, this will now be part 2, 3MF. Hit save, and just like that, it gets exported. Okay, so now we are ready to, like I said, start slicing. We went through the process of actually determining where this part is going to get sliced. We sliced it, we closed the holes, we inserted these keys with a Boolean mesh, and we exported these 2 separate pieces into a 3MF file that the slicer can read, and we can actually proceed, you know, by slicing and actually, you know, printing. So I'll show you that process next. Thanks. Okay, so now as you can see here, we are into we're into Super Slicer, and I took the lower part of the leg that we split, and as you can see, it was imported as a 3MF file. As you can clearly see, the 2 holes that we created for the keys are there, and so is the part. Now, as I said before, this part now needs to be scaled because none of that scaling was done in ZBrush. So just quite simply, I go here and I scale it to about 305% uniform scaling, which was basically about the size or so that I printed the model. And as you can see, now it looks pretty big. This is going to be a several hour print. Now, because we cut the part here, all I got to do is manipulate it on my build plate in this manner. You can rotate it to basically just make it fit the way you want to. Again, I have a pretty large build plate. As you can see, it's a RatRig printer. And, you know, looking at this, I really don't need to create a lot of supports. Now, there's going to be probably a little bit of supports needed here. I just go on and, you know, I create some manual supports. I'm going to go on ahead and then slice this model. And judging from, you know, the rest of the parts here, taking a look at the overhangs, I'm sorry, I really have no problem in letting my printer handle these. It's at a pretty, not a very steep angle, so I really don't need any support. So as you can see, just by the mere fact that this part was cut in the middle, it really allows us to eliminate a lot of the support structures. And again, I go back into before you slice it, before you cut it, make sure that you take into consideration how you're going to orient it on your build plate as to minimize the support structure. Okay. Now, with that said, this entire model of RMN, full-size RMN, was created in PETG. I happen to like PETG. It is a little finicky. It does require you to be able to, you know, go in and tune your printer to it. I'm using the RatRig with Clipper as my firmware. So I went in, I did all the pressure advanced stuff. You know, I made sure I have a high flow nozzle. And, you know, the other thing that this brings me to is the size of nozzle. Now, you can go on ahead and print this with a 0.4 millimeter nozzle and, you know, a low layer height. Now, understand that the lower the layer height is, the more time that it's going to take to print this. But in a model this big, right, with the post-processing that we're going to do, and I'm going to explain to you the process, I really wouldn't print it in with anything less than a 0.6 millimeter nozzle, right? This allows you to have a relatively pretty high layer height. You can print at 0.36. You can even go up to 0.42. Now, yes, you are going to see the layers, but if you're worried about details, there ain't going to be any loss of details, because the model is so large. Printing it with a 0.6 millimeter or even a 0.8 millimeter nozzle, it's not going to create any sort of detail. So I just want to assure you that that's okay. So, printing it with such a large layer height, it's going to minimize, the print time. Now, my printer is also Core XY. I really crank the speeds. I have a Dragon high flow hot end. And I'm actually, with some infill or some solid infill, I can get up to 30 to even 33 cubic millimeters of flow, which is pretty high. So, a part like this is not going to take, a day to print. And that's what I use. I can't go in and prescribe to you guys, here's what you're going to do. You're going to get the same output. It's just really depends on the printer that you're going to use. But I'm giving you some guidelines as to the parameters. I use a 0.6 millimeter nozzle. Some of my settings, 0.36, even 0.42 layer height. A couple of things that I really want to focus on is infill and perimeters. Okay. Now, my width, I have it set to 0.54, which basically with two perimeters, I can get over a millimeter worth of width on the shell, right? So the other advantage with printing with the 0.6 millimeter nozzle, and let me just dial that down a little bit, is that, here I print with 3 perimeters, and, bear in mind that this is part of the leg, right? And when this model is done, this leg is going to have to support the weight of the torso, the arms, etc. So you want to consider that, right? You want to consider the number of perimeters you're going to print, the width that you're printing those perimeters with, and with the 0.4 width and 3 perimeters here, this is going to be one strong part, okay? Especially given the layer adhesion properties of PETG. If properly tuned, you can absolutely, achieve similar strengths with PLA. Obviously, if you want to venture and you have an enclosed chamber printer, you can absolutely print this in ABS. In fact, ABS will sand better. I find out that ABS sands really good. PETG sands pretty good. PLA is the hardest to sand in eliminating those layer lines. But again, I'll go through the process with you guys so you can see how I'm able to achieve a very smooth finish. But I wouldn't print with anything less than a 0.6 millimeter nozzle. Now, it brings me also to another thing that I want to discuss here in questions that I've been asked is the infill, okay? You really don't need much of it, okay? A lot of the weight in this model is going to be vertically when, when it bears that weight. So you don't really need to go crazy with infill. In fact, I usually dial this down to about 3%. And I find out that even with 3% infill, as you can see here, it's enough to keep the part held together. And it's actually also pretty strong. Now, another thing that you can do here, especially if this model, had some additional things that must be printed on top, and if you do not have a lot of infill, those parts are not going to print as well. There's a parameter in Super Slicer, and it's called supporting dense layer. Okay, and by checking this on, it will allow you to actually dial down the infill. And let me tell you why. So as you can see, it's printing here, but as you can see where it needs to print that solid top part, it actually puts a supporting layer, these blue lines here below it, which kind of like bridges the gap in the missing gaps of the infill. And it allows the infill to print at a much better better way, if you will. It's going to look a lot better. Now, in this manner, it wouldn't really matter, right? Because you're not going to see this part anyway, but I still needed this part to print well, because guess what? The boot, if you will, the shoe of this model is going to be here. And I wanted this to be clean, and I wanted to be one that is able to support the weight. In fact, what I did, believe it or not, when I printed this piece out, I needed to test that. I placed it upside down, and I basically took my weight and I stepped on it. It actually supported my weight. So I have no issues in terms of this being able to support the weight of the model. 3 perimeters is more than enough, especially given a 0.6 millimeter nozzle with a 0.54 width. You can actually probably get away with 2 supporting layers. My recommendation to you guys is, experiment, obviously. You can actually print only a few layers of this model and then stop your print, maybe print up to here, stop your print so you can gauge how strong it is, place weights on it or whatever, just to ensure you that what you're doing, it's actually going to support, the weight of the model. But I found these settings for me to work. It drives down my printing time. I think total, it was something like 470 hours or so, which is, for a model this size, it could have taken easily 5 or 6 times that, especially if you're printing with a 0.4 millimeter nozzle, very low layer heights and high density. That is one of the things that when I see some people printing large prints, they really, use a very small nozzle, which ups the time, but they use a lot of infill. Now, granted, if it's a structural part and you need this, great, you could do that. But this is a display model, right? This is something that is probably, not going to move much. It's not going to weigh. I think I used a total of like something 17 kilograms or filament, PETG filament. And I was able to print the entire model at like 305%. And, yeah, so far, no issues. So I just wanted to give you that bit of an overview. As you can see here, very few supports needed. Place a little bit of supports here on the back, as you can see, as we get into this ledge here. You can see that I needed that. I wanted this to be nice and clean. What I also do with the nozzle, another thing that I want to show you here, is they use usually a 0.3 millimeter gap between the top and the bottom. Depending on your printer and depending how you tune it, I've gone as low as 0.24 gap. And this is for the Z offset of the infill, because I want those infills to also be able to separate easily, right? Again, PETG has a very strong layer adhesion. It depends obviously on the temperature that you print it at. It also depends on the type of cooling that you use. I use a little bit, something like, I think, a 30% fan here, especially on overhangs. If people recommend to print PETG with no fan, but I find out a little bit of a fan helps overhangs, and it helps it to print cleanly, and I still have no issues with layer adhesion. Again, it depends on the PETG. As you can see here, I have labeled this as Hatchbox. I believe my RMN model was printed with Polymaker. I used all Polymaker. I have good results with both Polymaker as well as Hatchbox PETG. I print a lot of PETG, and yeah, I found no issues. So again, make sure you absolutely scale the model. The percentage scaling is going to be for all the parts, right? As you import every single part, you'll scale it as much. The little keys, the little square cubes that you're going to print to be able to key this part. You can see here in the bottom after it prints, you can measure that. But again, take into consideration the scaling so you can know, what to print them at. You can actually print you can go to your slicer, as I mentioned before. I want to show you really quickly here. Let me just, if you want to create one of these keys, you can just simply go here and say edge shape box, and then you can go and, depending on the size of your scaling, you can actually create these keys and then print them. And then those are going to be the alignment keys, as we talked about, that's going to help you to align these two pieces together when you print them so they glue nicely. Okay, so that's a little bit on the slicer. That's a little bit of the process that I use. I just hit slice now, send it to the printer, and off we go. So I'm going to show you a little bit of that stuff going on, show you the printer printing. And then after that, we were going to go into more of a detail. Now that we have parts coming out, hopefully they're looking great. What is that process that we're going to follow in order to be able to put those parts together and make them look really great before we put the whole model together?